Welcome to this month's Self-Build Hour. I'm your host, Jenny Chandela. I am here at the National Self-Build and Renovation Center in Swindon, but my background looks a little bit different because it is a very busy day down there, so it was a bit noisy. So I'm up in one of the conferencing rooms. But just a reminder of what the Self-Build Hour is and how it works. Every month we bring to you an expert in self-build on a very specific topic, and that presenter speaks about their experience in that area. We have it live right now, so those of you who are attending live have the ability to use the Q&A function to ask any questions during the presentation. And those of you who may not have that functionality, feel free to pop those questions into the chat. At the end of the presentation, we'll go through and ask questions to the presenter. So please do use this opportunity if you're attending live today. But this is also being recorded today. So you have the ability to rewatch this again at a later date, or for any of the self-build hours that you may have missed, you can always catch up on those and watch them on demand. So very pleased today to be joined by David Macfarlane. He is the technical lead and associate at AC Architects, and he's here to speak to us today about the importance of a production pack. This is something that is slightly different from other residential architectural services you may have seen, but he's got a lot of experience in putting these together specifically for self-build projects and for modern construction methods to achieve that low energy build and to achieve that seamless transition, or as seamless as it can be, from drawing and design to the construction site. So without further ado, I'm going to hand it over to David to give his presentation.
Thanks, Jenny. Thanks for the introduction. I'll just share my screen now, and I think we'll just make a start on the presentation.
Okay. I can see that, and we can hear you fine. So I'm gonna exit and leave it to you. That's perfect. Thank you.
Perfect. Well, welcome to the importance of a production pack. My name is David. I'm an associate and senior technician at Allen Caulfield Architects, and I oversee and specialise in the detailed design and construction of low energy fabric first homes. Before we get on to the importance of a production pack, I think it's really important to understand the drawing stages of a self-build project. There can be a lot of confusion between what the packages will provide. So let's take a look at that now. Sorry. I'll just share that again. So typically you'll start with hand sketches or quick CAD drawings. They're easy to understand. They're very good at getting ideas quickly down on paper. They're great for looking at multiple ideas, and they're typically just in 2D format. We then move on to initial design stages. Now, these are more detailed than initial sketches. They'll set out indicative room sizes. We'll start to consider wall thicknesses and materials. We'll look at overall aesthetics of the dwellings and incorporate key features that you want to include. We'll set out window and door aesthetics. And generally, it's quite a heavily involved process to arrive at design that you're happy with. You might end up with 2 or 3 options you like, and then pick key features from each design to pull them together into one final layout. We then move on to planning. These are the drawings that will take the initial design and look at the key aspects we need to include on the drawings to support policy. It'll bring in other consultants' information like tree surveys, bat surveys. You might have an ecology report, a biodiversity net gain that you have to meet. These supporting documents are typically determined by planning to meet local or national policy. They show the context of the site and neighbours. You might have to include a streetscape and look at overlooking issues or overall heights of the dwelling. It'll introduce material keys so the planners can see what materials you're planning to finish the building, and it usually includes some kind of photorealistic images. You'll also get a full supporting design and access statement, so that's a written document that basically supports the design and it determines how it meets policy. But the goal here is to present a design to planning that will give it the best chance of success. We then move on to compliance or warrant drawings. Now, by this point, you should have picked a construction method by now, as it will be key in determining how the building performs against regulations. In Scotland, you'll need a building warrant, and in England, you can do a building notice where you just give the verifier 7 to 10 days notice, but we always advise a full plans application. This is an opportunity for the building control body to review the drawings ahead of site works, and it removes a lot of risk. These drawings will evidence how we comply with regulations. Guidance on how to meet the regulations varies across the UK. In Scotland, there's the technical handbooks. In England, there's a series of approved documents, and Wales have their own set of approved documents too. These are guidelines on how to achieve compliance with the Building Regulations 2010. Your architect will follow these guidelines when drawing out the plans to make sure the dwelling complies. Typically, this involves them looking at things like access, how do you move around the dwelling? What are the minimum widths to comply? The approach to the dwelling and any accessible services that are required. In England, check your planning approval. It will determine if a higher standard of approved document M is required, which is all about accessibility in dwellings. Fire protection and escape. We'll look at the structural integrity, the surface spread of flame, the escape measures required, any early warning systems that you need, access for firefighting and emergency water supply. Ventilation, we'll look at that as part of compliance. Is it going to be natural ventilation or mechanical? What provision is there for purge? Looks at daylight provision. So we'll need a minimum daylight provision for each room. If you exceed the standard, you'll need to look at overheating and how this affects your performance in SAP. That's Part L in England and Wales and Section 6 in Scotland. You'll look at protection from falling. What safety barriers do you need? Full height glass needs to act as a barrier. If you've got any full height feature glazing, it needs to have barrier loading so you can't just fall through the glass. Do stairs comply? What balustrade types and styles are you using? They all need to be considered at this point to make sure that they comply with regulations. We'll then look at thermal performance. This requires a draft SAP, which is a standard assessment procedure. This is the software that's used to determine your EPC. So it gives you that rating from like A to G, and it determines how the building performs against regulations. You'll look at sound performance, of intermediate floors, intermediate walls, anything that we require to get that sound compliance to comply. And then we'll look at the coordination of the structure. What's the structural design? Are there any supporting calculations? Do we need to send them to the verifier in England and Wales? And in Scotland, you'll need a structural engineer's register, which is an SER certificate, which just means that a certified engineer's overseeing the design to make sure that it's structurally sound. We then move on to production stage. Now, this is the last stage before going to site. These are the sets of drawings and schedules that allow the key elements of your build to be produced. These drawings are going to get you to site and typically involve the following: foundation setting out, kit setting out or manufacture, window and door manufacture, main services setting out, and typically 5 to 10 key details for site. There's so many aspects involved in all of these stages that we've just reviewed that we could probably host a self-build hour on each one of them. This was just a brief overview to highlight the key differences between packages. Now, before we move on to the specifics of a production pack, let's look at some reasons not to go to site. So if you've not got a production pack, you've just received compliance or warrant approval, this is compliance only. It does not mean that you're ready to build. Getting your provisional license doesn't mean you're ready to drive. Compliance drawings only. You've ticked a box because building regulations says you have to. You can go to site if you like, but it's entirely at your own risk. Your contractors will more than likely curse about the level of information. It's not what they're used to. They can't build from these drawings. They're not for construction. They're for compliance. No one should be building from them. That's not your architect's fault, and they probably made it clear these drawings are not for construction. Check the drawing status down the bottom right-hand corner or left-hand corner. It should tell you the status of the drawings. If it's for compliance, it is not for construction. Check in with your architect. What are the next steps so you are ready? Another reason we see clients rush to site is your kit manufacturer has a slot in their factory. This one is understandable because they have schedules to work to, tight programs to get everything fabricated and out the door. This doesn't mean that you rush and go to site. There's always a slot in the factory. It's about finding the right one for your project. Everyone else's kit is already there because they also booked a slot in the factory. The last one, we get this a lot, your contractor's going on holiday. Now, when they come back from holiday, are they no longer in the trade? No. When they come back from holiday, are they going to decide they don't want your job anymore and would rather give it to someone else? No. These are all reasons we have seen time and time again where the rush to site happens and things don't go as planned. Please don't do this. So what are you getting in a production pack that makes the difference? We touched on those drawing packs earlier on in this talk, but let's have a look at them in more detail now. So step one is your foundation setting out. This will set out the foundation sizes and location on the site based on the type of foundation specified. You might have strip footings, are there varying widths and depths to be set out across the site? If there's trench fill, some sites vary front to back. You might have 1.2 metres at the front and 1.9 metres at the back. If it's a ring beam and piles, what's the pile contractor's design? What sizes are the piles and are there clashes with any services? What depth do they need to be driven to? Where's the piling map being set down for access for the piling rig? What capping heights do we need across the site to suit varying slab levels? If there's a raft slab, where's the perimeter of the concrete in relation to the insulation? All the drains need to be in place before concrete. So who's setting them out and where are they going? Do those levels still meet the invert level of the disconnecting manhole on the site? So with a raft slab, you're spreading the concrete across the site. You're going to have drainage that has to be coordinated there first before that concrete works happen. But what are they tying it back to? This would all be set out in your production drawings. In this project, there's varying heights and foundations to be set out. You can see across the top left here, we had a suspended concrete slab. On the lower front here, you could see there is a raft slab at lower level, and then this was a stepped tiered site. So the upper level had, at the back here, had a ground bearing slab. So there was 3 different slabs, all to be coordinated on this project. The tops of foundation all had to step. We had to determine where those steps were, what lengths were they, what height were all of these top of foundations. Your contractor can ask for coordinates to work to. In this project, we took the drawings, we issued them in DWG, and the surveyor used them to set out one site. Sometimes if you're in a contract with a ground worker, they'll actually ask for coordinates. That can all be added to the drawings and tied to easting and northings, ordnance datums on the site, and issued as part of a production pack. You'll look at foundation corners and slab corners. There might be brick or block lines. You might have block work above and below the slab level. So you might have, like in this suspended slab, in this suspended slab, you might have like a 215 block on flat up to the underside of the slab for structural support, and then a 140 block work above that. So that's 2 different block work setting out drawings that you then need. They would all be provided as part of a production pack. You'll look at pop-ups through the slab, service ducts, how are services getting in? That's all going to have to be cast into the concrete. You can't add these ducts in after. Are there any key features that need built in? Is there floor sockets that you want to consider? Is there a sunken lounge? Is there services to the kitchen island? And, a lot of clients don't think, I'll put a tap there, I'll put a dishwasher there, but they all need coordinated with your foundations, with your drainage layout, all your pop-ups organised and arranged and dimensioned out to set out on site. It'll look at the foundation levels and clashes with services. We as architects will determine the top of foundation, but engineers will coordinate the bottom of foundation and good ground. So where is that top of foundation sitting? Where is it relative to the invert levels of the drains? Do we need to drop that foundation level to get those drains to work? You don't want to be slaving through concrete with drains. You want them to pass over the top of the foundation. Just use a standard lintel over the underbuild wall and lintel the drains through that way. Does the foundation need to drop to accommodate these levels? And then even your floor levels with your slabs, Where is your screed? Where is your insulation? Do you want to thicken that insulation? This all determines levels and how those foundations work. It'll coordinate the blockwork setting out, any slapping out that you need. So this is where block is locally removed. It will consider those areas so that you can tie that in with thresholds for your doors, sliding doors, hinged doors, any level thresholds you want to consider. It will look at base plate sizes and heights, and any threshold packing for windows and doors as well. So once you've knocked that blockwork out, you might then want to pack it back up with insulation to get your doors and full height windows to then tie in with your finished floor level. As part of this foundation setting out, you'll need to look at key aspects for site setting out as well. So you'll coordinate root protection areas and their relationship to footings, any hand dug areas to be highlighted on the plan. So here you can see the surface water had to pass through the root protection area, and there's a note on there to coordinate that with the arborist, and it has to be hand dug and inspected. What ground protection measures need to go in and where? So if these root protection areas did encroach into the access to the site, what ground protection needs to go in there. It'll give you a full coordination of drains and levels. And this one was a raft slab, so setting out the drain prior to the slab being poured meant that we had to determine all of these chambers, invert levels, the falls. We worked with the civils designer so that all of that could go in before the concrete works. Step 2 is your kit setting out or manufacture. So this will vary depending on the construction method you choose. If it's timber frame or SIPs, there will be a review and coordination of the kit drawings with the factory. The drawings are usually issued to the architect to review and comment. There's massive coordination that goes on with connection details and steels. There's end plates. Are they bolted or welded connections? Is there any co-bridging that we need to look at? It'll also consider the sole plate setting out. That's the timber that the kit sits on and its relationship with the foundations. What is the kit width and the block size the kit needs to be to sit on? Where will the DPC be lapped? How wide does this need to be? Some DPCs need to lap up the kit, some lap down the kit. It all comes down to foundation type and how this interacts with the kit and surrounding ground levels. So again, this will all tie back in with your foundations. Where's your foundation in relation to your kit? What waterproofing, protection and DPC measures need to go in place and how are they being detailed out? If there is steel, where does this sit in relation to the kit? What cold bridging is there to contend with to meet thermal efficiency and SAP? Are there psi values with the kit that need coordinated or reviewed? These are specific heat loss calculations through linear junctions, and many kit providers have their own performance data to use. What are the performance levels of the kit? The insulation, the air tightness. Many kits have different upgrade options, but which one do you need and what implications does this have on the overall project? What membrane is being supplied to the outer face of the kit? Most membranes are a Class W2 standard, but you might need a Class W1. If you've got open jointed cladding or you want to improve your air tightness on the outside of the kit, you'll need to upgrade that membrane and include that in the cost. What's the floor specification? Is it solid or engineered joists? Is there JGIs or pauses? And how does this affect your services? So this is all coordinated with the kit manufacturer and with your architect. Is there an air barrier supplied at mid-floor level? So a lot of these prefabricated kits, clients pick them because they're precision engineered, they go together and they improve the air tightness. If you don't include an air barrier at key junctions, then you're losing all that air round the perimeter of the building. So is that included in the kit? Where is it going? How is it being installed? How is it being lapped and sealed to all the membranes that come in after that? Do the floor levels vary across the job for terraces and balconies? There's a lot of step changes in levels between inside and out. Where are those services going? Who's coordinating the holes in the steel? These are all key elements that are coordinated with your kit manufacturer. Are there any upgrades you can make to the sound compliance? Some clients want to improve sound performance, but who's coordinating this on the drawings? Does that sound improvement increase the joist size? Does it affect the floor-to-floor heights? Is there additional loading that goes on the joist that then needs to be passed to the engineer? What are the final apertures in the kit to suit the windows and doors? All of this is coordinated with the kit manufacturer and your architect. What's the connection for the stair to the floor edge? You might just go ahead and order your kit, but you've got to think about all these other items that follow-on trades will come to site with. If there's balustrades or there's stairs, how are they being connected? What structure is being provided in the kit to connect those features back to? Is your balustrade top mounted or side mounted? That all makes a difference on what structure is provided and how that balustrade is fixed back. Is there a lift shaft to set out and coordinate? What size is it? What size is the lift pit? How deep is the lift pit? What structural support do you need, and how does this affect the foundations and structural design? So all of that needs coordinated with the structural engineer back into the kit engineering, and all of that transfers down into the foundation and can affect your foundation design. Are there any external Juliet barriers, and where do these fix? What's the type and style, and is there support in the kit for fixing them? Your architect should be advising you and coordinating all of these items as part of your production pack. If they aren't coordinated now, you need to work solutions on site that might not give the desired results. Looking at ICF, if there's kit setting out, it's all coordinated as part of the prefabricated kit. Everything that you do with a prefabricated kit should apply to ICF as well. It just won't go through the factory and there won't be kit drawings from your manufacturer to check. So your architect should provide setting out drawings. In this project, there was packing requirements that varied across the openings for windows and doors. So you can see here in orange that there was different packing to each opening based on whether it was a sliding door or a fixed window. This was all set out, all the levels were coordinated, all the apertures were coordinated, and this allowed the windows and doors to be signed off. So it meant the contractor could start on site, the client could order the windows and doors, and by the time the apertures were formed, the windows and doors would arrive and they would fit on site. What packing do you need to suit your doors? If there's different thresholds, in this one specifically, there was a really deep threshold because there was a concealed drainage system. If that's not a concealed drainage system and the threshold isn't as deep, how is that being coordinated with the final levels and the structure? Again, what balustrades are you proposing and how are they fixed to the concrete core or slab edge? And how does this affect finishes and levels to conceal fixings? So in this project, it was ICF. Typically, in ICF, you might have an intermediate concrete floor, but we had to include screed and a floating floor over the top so that we could conceal fixings for balustrades, handrails, stairs. All of that was then hidden. It will coordinate the services through the structure, apertures in the wall heads, and anything through the slab or through the wall for MVHR. So all of this is being coordinated. You can see it in red hatching, where all the holes need to come through the wall to coordinate the MVHR. Now, this is an example of a fully coordinated system. We considered MVHR, structure, balustrade type and style, and window and door package. And all of this needs considered at design stage. If you're using ICF, concrete intermediate floors are common and you'll need these levels set out. So again, in this project, we had multiple slab levels across the project. So there's 4 slabs here. We had the suspended slab at one level, the ground bearing slab at another level. We had the intermediate floor slab and then the lower raft slab. These were all coordinated because they had to all be at different heights so that when the finished floor level came through, everything tied together. There was voids through the floor that were set out. These were all considered to the slab edge in relationship to take the future balustrade fixings. So all of these apertures were coordinated to make sure that that all tied through with final finishes. Service holes in the slab, again, you can see them all marked in red for the MVHR. This was fully coordinated with the service provider and their design to ensure it can be fully installed and commissioned on site. Again, where are the drains going? Are there any freestanding baths or floor-mounted toilets that need holes through the slab? What about wet rooms? Is the whole room drained centrally, and where is the drain connecting? These all have implications on how the building is set out. And you've got the same here with the connection for the stair. It's a concrete floor, so you might want concrete stair. If it's precast, what's the connection detail? What's your floor finishes? They all need designed in now and coordinated to this, so the stair can go to manufacture. It's likely to take 12 to 16 weeks to come to site, so you really want to build that in with your program, so it's coordinated with your architect, it goes to fabrication, and by the time they're up to that first floor level on site, the stair's there, ready to be installed. Step 3 is window and door manufacture. Now, this is a big part of the project and varies massively depending on the window manufacturer and final aesthetics. Schedules will be coordinated and detailed out with the supplier, and is usually a heavily involved process to iron out final fitting details. You know, what's the material? Does the alu-clad element need vented? What's the fitting tolerance? These all vary from manufacturer to manufacturer. Is there a transport packer, and do you need one? This is a packer that goes underneath the unit that allows a future fixing of a cell. Do you need that because it alters the unit size? What's the relationship of thresholds at ground and first floor levels? Do you need a hidden threshold? Where are the units draining to? What's the window ceiling specification? Different systems on the market, but it's the right one that's being provided for. Is it the right one that's being provided for your build system? Is there a sill packer or frame extension you need, and how much of the frame can be concealed? You know, different manufacturers, timber alu-clad, sometimes require a vented gap all the way around the perimeter of the window. Others don't, and you can conceal that frame or embed it into the structure. Where are the handle locations? You know, which way will the windows open? Are they inward? Are they outward? Are they sliding or tilt and turn? Will that operation of the window clash with any Juliet barriers that you have? Do the units comply with fire escape? Different manufacturers have minimum unit sizes for escape. So does that still comply? If you've got something with quite a thick frame, once it's open at 90 degrees, that frame can interfere with the final opening and affect the fire escape compliance. What's the glass specification? Has the engineer checked for wind and barrier loading on the site? Is there any opaque glazing to meet planning or privacy preferences? And is there a G value that you need to meet for overheating? So this is the solar reflectance value of the glass, and how much of that is coming through the unit and causing overheating. Part O in regulations now requires a TM59 detailed calculation if your glass exceeds the floor area percentage that you're allowed under compliance. So you really need to consider that G value now at design stage, so it can be built into the schedules, checked by your architect, and ordered at production stage. It will also look at the coordination of the sill type and depth. Are the sills provided deep enough to flash over your finishes? The minimum advised protection is 40 millimeters from finishes. Is this sill being supplied with the unit? In this case, it was. So there was a groove in this is a rationale window. There's a sill here that tucks into a groove in the frame of the window. That meant that it could be supplied with the window and installed on site. But if that wasn't there, there would need to be a transport packer or a frame extension, something to fix the sill into. That all affects the unit size and aperture size for the kit, which is all coordinated at production stage. What's the lapping and sealing of the membranes and tapes? These are all detailed out so that follow-on trades know the specification and taping measures to achieve a lower air tightness level. In this specific project, the relationship to finishes were detailed as these units required a minimum ventilation gap all round to vent the timber element of the alu-clad units. So these finishes were all returned into the face of the kit to leave that minimum ventilation gap to the alu-clad element of the unit. These are all key details that are coordinated at production stage. The units were also arranged so the coupling between each item was in front of the structure to give a minimalist look, tying in the structural sizes of the steel with the frame width. So you can see here, this is two windows coupling together, we had to make sure that when the two units came together with the coupling piece from the manufacturer, the steel could sit nicely behind that and be concealed so it all looks part of the one system. This same project had a glazed gable that was fully coordinated. We looked at the threshold type and its relationship to surface drainage. Windows this size couldn't simply be stacked, so they required flitch plates, which is a small section of steel between the units to give extra rigidity. Those then get sealed with a gasket, so that flitch plate has to all be built in between the units, the tolerances adjusted so that you can get the window to manufacture. The windows to the intermediate floor were replaced with spandrel units. This is where the factory replaces the glass portion of the unit with an insulated panel. That's usually powder coated to the same RAL colour as the units to give a consistent look. Those units had to be supported structurally and tie back to the floor. So there was a rolled steel angle was introduced to act as a flitch plate and a bracket to fix the units in place. So you can see that unit here at ground floor level. There was then a rolled steel angle fixed back to the intermediate floor in an L shape. The spandrel panel was supported off that. A bracket was then tied back to the top of the floor. All of that had to be coordinated with the joist size, the final floor finishes from the client. You know, what's the floor to floor height? This was all coordinated with the structural engineer, the kit designer and manufacturer, the foundation design, the window and door manufacturer, and it's all part of your production pack. They had trapezoidal windows. So on top of these spandrel windows, the trapezoidal windows had to meet the angles. It had to meet the pitch of the roof. We had to consider finished ceiling levels. You know, we had to coordinate with the client light fittings. You know, were they considering on putting recessed lights in here at the ceiling level? Because if they were, and that ceiling had to be dropped even further, that would clash with the frame. So the plasterboard would run into the glass rather than into the frame. That would all affect the unit size and final finishes. And this is the finished result on site. So everything aligns as it should. The aesthetics the client wanted were achieved, and it was a very heavily involved process between all design parties, coordinated with your architect as part of their production pack. So these are the spandrel windows. Here's all the trapezoid windows, the sliding doors to the base here, and the steel post that we looked at is hidden exactly behind that frame. So you can't see it from outside, and it blends in seamlessly from the inside. This was all coordinated on the drawings, setting out the sizes, final finishes, tolerances, brackets, everything you could think of to get that to manufacture. That's part of a production pack. This is another example of windows and doors. They vary massively, so I've got a few examples for you here. This was varying threshold types across the project because it was a steep site with tiered levels to suit the rock head. This meant varying floor types were used. Some were ground bearing, some were suspended. Those floor types meant that limited threshold options were available. We also had steels connecting at blockwork level with base plates that could clash with door thresholds. The plate heights were coordinated to a height that meant the bolt heads could be sealed and finished below the doors. This was all coordinated with the kit manufacturer and their in-house steel fabrication team, exchanging drawings and 3D models. We also had to consider sequencing on site, as the rock head meant there was restricted access below the upper floors. So the deck to the timber floor was supplied loose to gain access for fitting insulation to the floor at a later date. So you can see here the timber joisted floor was suspended above. The foundation was actually anchored into the rock head here. The deck was then supplied loose above those joists so that the insulation could be fitted at a later date. That meant there was no deck for the door to sit on, so additional timbers were added in there so that the door could be recessed down and the client could achieve that flush internal to external finish. Here's some further threshold options that we looked at because there was balcony features, a lot of step changes in level. One key detail was a partial balcony enclosure to a portion of the flat roof. This required steel posts to be projected through the roof, which had to be thermally broken from the heated space below. The handrail was then fixed to a steel PFC that bridged across the posts. This allowed the balcony to drain below the handrail to the designed outlet locations. No structure or drainage could be directed below, as this would interfere with the open plan space underneath. So here is the steel. We've got the beam above the sliding door. From there was steel posts. These were broken with a thermally broken fixing. We then had the PFC across the top of these posts to support the handrail. It meant the surface water could drain freely underneath because there was no outlets allowed inside or under this balcony area because it was a fully open plan lounge area. And here's the solution on site. Not quite complete, but the posts are there. You can see them. They're fully sealed and thermally broken, ready to receive the supporting steel and balustrades. The windows and doors are all fitted and coordinated with the exterior cladding, allowing external cells to be dressed into transport packers below the windows so they could be fully flashed and sealed. So these windows couldn't come with the standard sill, so they had a transport packer that sat underneath the window unit that allowed these flashings to be folded up and fixed into that transport packer. If that wasn't there, you'd be trying to fix this flashing into the frame of the unit, which you just can't do. This was a fully collaborated package that was delivered to site, which only comes with an architectural production pack. The last example on windows and doors coordinates all the elements required to obtain concealed frames, flush thresholds, and a minimalist look. Generally in construction, the less you see when it's finished, the more detail and coordination that's went into the design. These units in particular had deep thresholds and concealed drainage all built in, so a lot of space was required to fit these units. This meant step changes in the slab had to be designed and coordinated. With the floors being concrete, intricate steel detailing was set out to support the doors and conceal the thresholds to achieve the desired aesthetics. So you can see here in this top right detail, we had a concrete intermediate floor, a joisted balcony on the outside. That meant there was two different steel levels. One was to support the joisted floor, one to support the concrete floor. Those two steels were then joined with a steel plate, which meant a concrete bedding could be cast on top of that steel plate to give the support to the door that it needs. These were heavy units. We weren't allowed much deflection in them, so it had to be a concrete base they were being fixed back to. And then all of that was considered with levels, so the structure could all be concealed within the depth of the floor zone and get that flush finish inside to out. This has coordinated your drainage, your air tightness, your thermal efficiency, your steel fabrication, everything that you need to get to site. Again, you can see the thresholds fully coordinated and concealed in these details. The frames of the windows and doors were embedded to obtain a seamless inside to outside transition. The soffits were all angled to reduce the roof edge depth and not compromise on the structure. They angled into the window units to achieve that minimalist concealed frame aesthetic. The corner sliders were designed to open from the corner, so this pushed the structural steel support inside the building, keeping it warm and thermally efficient. The setting of this post was made a feature and accurately aligned with the corner glass to achieve the final aesthetic the client was looking for. So let's look at these features completed on site. So here you can see the frames were fully embedded. This was all coordinated with the slab levels. This was the suspended slab, which meant the insulation and screed was laid over the top. That gave us space below the finished floor level to conceal all the frames, the fixings, the weather tightness, the thermal broken fixings. Everything was concealed here. The client also wanted that transition of the stone inside to out. So that meant that we had to coordinate all those unit sizes, how were they recessed into the structure, so that when the final finish is dressed up, you wouldn't see any of the frames. Now, the photo on the right here is that threshold detail that we just looked at. So if we go back here, all of this structure that's being considered below the intermediate floor and below the balcony, all of that steel all the air tightness membranes, the insulation, the tapered insulation design, the single ply membrane waterproofing, everything is all concealed below the threshold of this door. So it gets that seamless transition inside to out. This is not part of a compliance package. You won't get it. It's part of a production packet. This is the corner post you can see. So this is the client looking for that seamless transition again, inside to out. This unit actually opens in the corner, so they can slide back both units, and then they've got that transition from inside to the outside space in the balcony here. And the key feature here was the client wanted it powder coated, sent to site, so it had to be protected on site. We had to consider the height of the steels, the levels, all the bolt fixings and connections are all hidden below the base of the steel, so that when the finished floor level all dressed in, everything was hidden and seamless. Again, looking at the windows, these were all the frames were all embedded into the plasterboard. The floor finish dressed right up to the frames, so you can see there that seamless transition. There's so much detailing and work that goes into this in the production pack that meant the client could order the windows, the contractor could continue on site, and when the windows arrived, they would all fit and get that final aesthetic. This is the glass link from the outside. So again, you can see the transition from the stone inside to out. And just a lot of these windows, like, you know, the rainwater pipes, the gutters, the standing seam, everything was coordinated. There's a hidden gutter across the top here that was all concealed within the cladding. So it meant the cladding had to be batten, counterbatten, and counterbatten again to get the gutters and rainwater pipes all concealed within the cavity. This pack is so important for achieving these features, and without it, the impact on aesthetics could have been detrimental to the whole project. So let's look at step 4, your main services setting out. You know, we would consider what ducts do you need in this lab and their size. Where are the ducts going? Do you want spare ducts for future services? This ties in with invert levels and drainage strategy, which all needs considered in foundation design and levels. What renewables will you have? You know, is there an air source heat pump or a ground source heat pump? And how does that connect into the equipment in the plant room? Do you have a final PV design that needs coordinated? And how is that routing down through the structure back to the battery storage or the meter? So this is all considered in your services setting out. This one was fully considered at foundation level, so you can see there is a suds pond, there was surface water, the invert levels were all coordinated with the slab. We had ducts here, you can see in green, which all came into a service riser, which then came up through the building and distributed throughout all 3 stories. This is an example of a ICF setting out. So we're looking at MVHR locations and quantity. All the blue hatched areas here you can see are service zones that were cut through the wall. So they all had to be cast in situ. So they usually block out the wall before they cast the concrete, so it leaves an opening. We don't want to be going round a concrete structure with steel and rebar and everything else that goes into that structure to make it structurally sound, and then trying to cut holes everywhere for large service ducts and MVHR. You know, think about these duct routes. Think about where are they going to go in the building. Think about future cooling. We have clients that don't want a cooling system now, but they might want one in the future. So coordinate that with your architect and build it into the structure. Looking at step 5, these are key details for site. So typically you'll get 5 to 10 details to guide contractors on site. It should be listed in your fee. If not, ask your architect, what details are you getting? It will look at threshold options for ground and first floor that coordinate with your window and door package. You may require intricate details for final finishing, like feature window reveals or window seats. You know, these are all things that would be considered at production stage. It'll coordinate your underfloor heating and specification. So usually we get a design from the underfloor heating designer, We might get manifold locations. How are they being tied back to the manifold? If you've got a glass link, you usually split up the manifolds because you might have a thin corridor that you've got to get all the manifold and loops back through to. So you might split up the manifolds, but that all needs coordinated in production. How are those services getting through the concrete, through the structure, and to the upper levels? It'll coordinate your flat roof walls. Is it tapered insulation, or are you looking at fitting timbers? If it's a tapered insulation design, we'll usually go out and get a contractor designed element, but that will be coordinated. Looking at your thresholds and your balconies, that tapered design will need to be coordinated to make sure that you've still got the minimum upstand that you need at thresholds. It will look at the heat pump loops or ground collection manifold. So if you've got a ground source heat pump, you might have a ground collection manifold outside the dwelling, a bit like a manhole, and then that all comes in through a service duct and into the plant room. It will look at interface details. How do you want those finishes to interface? So looking back at this finish, all of these interface details between the render and standing seam were all considered at production stage. You'll then look at stairs. Coordination of stairs is really key. If you're looking at a feature stair, again, this takes us back to coordinating it with the structure, with the kit manufacturer. So consider your stairs early on. If you want a feature stair, it really needs built into the construction of the either ICF or kit or SIP system. Has that structure been allowed for? Where are the connections going? Are those connections going to interfere with any finishes? Do we need to float floors to conceal bolt heads and fixings? A lot of these structures are quite heavy, so you might need to increase the gauge of the steel in the floor to support the stair. So go out to your stair designers, speak to them about how you want the style to look, how is it going to be fabricated, how is it going to be connected back to the structure, and coordinate that with your architect at production stage. For compliance, all we need to show is that the stair complies. It's got a rise, it's got a going, and it's got a handrail to stop you falling. That's it. This is really key for getting a stair fully installed and coordinated on site. And this is the finished result. This is what happens when you get something prefabricated, designed, and coordinated. So the structure and the floor was there to support the stair. It was all fully considered. Connection details were coordinated, which allowed for finishes so they could be concealed. And this was all part of the production pack with the architect. So now you know a bit more about a production pack. What are the next steps? If you have a production pack already, continue to collaborate with your design team. If you need a production pack, ask your architect to provide one. But the key elements to deliver works don't stop here. Who's checking it on site? You've got that production pack, you've done everything you need to do to prepare and produce everything for site, but who's checking that on site? All that time that's been spent on a production pack to coordinate and get it right. Your architect can assist and check the works on site. It might just be 3 or 4 hours a week. It's not much, but over the length of a build, it can add up. If you're on a 60-week build program, that's a lot of hours for your architect. So appreciate the value that this brings to the project and work with the architect to get it right. So to summarise, a production pack is a heavily involved, coordinated process that gets everything you need checked and produced for site. The key to a successful production pack is all about timing. You don't have to wait or delay the project. You can get that kit in the factory slot and book your contractor before they go on holiday. You do that by getting your architects to run your detailed design and production pack in tandem. This means all the key points we just discussed and addressed are fully coordinated early enough in the project to be fully detailed out and ready for site. Thanks for listening, and I'll now go back to Jenny and see if there's any questions.
Thank you very much, David. That was very informative, and I think everyone can now see, given how long it takes to really describe a production pack, how much goes into it. It's a lot in there, and it's a lot of technical information. I think a lot of people look at a production pack and think it's technical, and then seeing these details now, you can see just what goes into it, and all these details that look really nice, or the images that look really nice in the renders, require coordination and thinking about how does that actually happen, and how do those materials interface.
Yeah, definitely. So, it's really key to get the aesthetics that you want, even if you don't want your client or your architect, sorry, to do a full production pack, even if you get them just to coordinate your kit, your foundations, and your windows and doors. They're the key elements. They're usually the most costly packages. So it means you've got that protection, that peace of mind. It's been checked. It's all going to come to site, and it's all going to fit.
Yeah, absolutely. And you mentioned SI values several times.
Yes.
Can you just very briefly, high level, say what a SI level is?
A SI value is basically, if you look at a U value, most people know what that is. It is the heat loss through a surface area of wall. If you look at a SI value, it's the same heat loss calculation, but it's through a linear junction. So it might be where your wall meets your roof. It might be where your roof meets your ridge beam. Round the perimeter of your intermediate floor. These are all cold bridges. Try dealing with the ones that repeat the most. So like your perimeter around your intermediate floor, your perimeter around your ground floor. They're going to impact your SAP the most and really bring that heat loss down.
And so it's really looking at the heat loss, and a lot of this comes back to stage 3, the SAP calculation, however, or the detailed design building regs compliance. But if it's not detailed correctly, then it won't.
Yes.
So those detail you can put in the calculations, but until the kit manufacturer and the contractor and everyone on site knows what that detail actually needs to look like in order to achieve that SI value, the SI value is somewhat irrelevant.
Yeah, it's
without the detail.
Yes, it's usually considered at detailed design stage for a performance level, but how you meet that performance on site is then detailed out at production stage. So there might be a target value that's applied in SAP, but building control now under the new Part L regulations actually want photographic evidence of bridges, because I think they've discovered that contractors are saying they're doing something, but they're covering it up with plasterboard and they're not seeing it. So they now want evidence, which all then goes into your SAP calculation. It goes back at completion stage for your SAP assessor to come out, which then produces your EPC. So all of that evidence needs to be supplied as supporting information to make sure that those cold bridges have been followed. And that's what your production pack will include. It will look at all of those keys details, tie them back to the SAP, make sure that they comply. And again, if you get your architect to come out and review it on site, if it's 2 or 3 hours a week, they're checking it as well. So you've got that peace of mind before the structure's covered up. You've done what you need to do to deal with those bridges and get your EPC and get your compliance.
We have a question about sort of specialist design, so MVHR, heating, even structural, and maybe even stair. And the question is there not a conflict of interest between the specialist details and the architectural production pack, or is there not an overlap, and how is this really coordinated without stepping on one another's toes?
So that's why we try and get clients to pick these systems. So pick their MVHR, pick their stair design, pick if they've got any lifts, pick what those models are, and get those designs done by the external contractors. Then that can all be brought into the architectural drawings and coordinated with your architect. It's not really a clash of anything. It's more a collaboration. So you'll pick up the phone, the architect will speak to the stair designer and just say, we've got a steel beam here where you're connecting. Can you adjust that level? Can you fix it at this point instead of this point? The stairs coming at a later date. Is there anything to consider about that future connection? what will be in the way? Can you get your hand in and still, tighten up the connection to make sure the stair's fixed? That would all be coordinated with your architect and your stair designer. The same with your MBHR designer. We would get that design from them. We would coordinate it through the structure. We would send it to them for comment, make sure that they're happy as well, that we've got enough space for the ducts, that they're being grouped together where they need to be. They're passing up through the floor where they need to be so that they can all be branched out so it can be commissioned and balanced at completion.
So it's really much more, as you say, a collaboration, and it makes everyone's lives sort of easier and flow better in the installation of the systems as well. So it's a benefit to everyone to make sure that multiple people are looking at it and looking at how all those systems come together. And it is usually your architect who's aware and has the information about all those systems to be able to do that coordination effort.
Yeah, and you don't want your architect just going off and making assumptions because you've not made choices, and then you pick a different system, and then that's when issues arise on site because the system you've picked hasn't been coordinated, that collaboration hasn't happened. So it's much more difficult or costly to install on site.
One last question. I'm aware of time, so I don't want to keep people on too long. But and this question is a bit like how long is a piece of string, but how long does a typical production pack take?
So it depends on the complexity of the design. But I'd typically say, if you allow 4 to 6 weeks for a production pack, that's usually enough for self-build projects that we work on across the UK. Build that time in and make sure it's considered. If you do want to get that slot with the factory or with the window manufacturer, or you want to beat a price increase that's coming in a couple of months' time, pick up the phone, speak to your architect, pull your production pack forward and work it in tandem with your detailed design so that you are prepared, you can meet that factory slot, you can miss that price increase in the windows and doors.
That's great. And I think it's also important to understand that while your building control, your full plans check is being undertaken by the building control officer, you can continue on with your production pack. There's no need to sort of stop and pause progress at that point.
No, definitely not. We can start all of those production drawings. We can start conversations with your window and door manufacturers, your kit manufacturers. You can then get those first set of comments or responses back from building control, and then anything that they are concerned about to meet compliance, you can build that all into your production stage and make sure it's fully considered and detailed out.
Lovely. That's great. Well, I'm gonna thank you very much for your time and expertise. If anyone needs to get in touch with us about a production pack, has questions about those production pack, just get in touch with David at acarchitects.biz, and we can answer any further queries. This will be posted online later, so there's a lot of information that was included in it. You'll be able to go back and have a look at it in further detail at a later date. So I'm now just going to wrap up with the top tips that I had jotted down during the presentation. So number one, do not rush to site before you have all the necessary documentation. You won't be saving time or money. Foundation setting out is essential to a successful start on site. Off-site manufactured items require formal review. Your window and door schedules and details are both specific to the window door manufacturers as well as your specific kit and kit manufacturer. And finally, if you're going to have feature items in your project, do keep in mind that they require bespoke details, and the earlier those details can start, the better. So in closing, we do have some in-person offerings coming up. At the beginning of the year, there will be a home building and renovating show in Farnborough. That is 17th and 18th of January. And then later on in the month, the NSBRC has its big January winter show. It overlaps slightly with February this year. So it'll be that last weekend in January, the Friday through the Sunday. So you can get a lot more expert advice on all of these items. Please, if you do come to any of them, stop by and say hello. And next month, we are going, instead of the second Thursday of the month, due to the timing in the month and all the holidays, we've decided to have our self-build hour on the third Thursday of the month. So that's actually Thursday, the 15th of January. We will be joined by Alan, who's going to be talking to us really about programming and what the considerations are if you want to get started on a project, what that looks like, and what are all the things that can affect your overall project program in terms of design considerations and decision making. So please do join us for that. Same time, same platform. So we'll be at Teams at 1 p.m. But the third Thursday, 15th of January, we will send emails out. Thank you so much for joining us again, and we look forward to seeing you after the holidays. Everyone have a safe and festive break.